Welcome to my channel. In this video I will try to repair this garage opener. Its model is Somfy. It's a French company. I already removed the screw, so I can remove the cover. Here we will find the motor with its worm gear reduction. Here it's a 24-volt motor. We can remove the PCB. The model of this garage opener is Dixo Optimo RTS 240 volt and the power is 120 watt. I found this on site. It's for the varistor, so it has an exploded varistor. Maybe it has an over voltage. Here we can find the trace of the explosion, and here I will now try to remove the PCB. Now we can see, we can find here the varistor is damaged, and we have the capacitor, a budget capacitor here. I will verify if the transistors are okay or not. Now I will remove the main capacitor. This is the primary smoothing capacitor. And now I will remove this power resistor. It's used to reduce the charge current to the capacitor at the startup. When we plug the power, it will reduce the inrush current. So this one, it's 4.7 ohm. I will measure it again. I have nothing, so it's gone. This one, we see if the short circuit here or there. Nothing, so we have here, we still have a short circuit here in the secondary and the primary. So I will test those MOSFET. We have two MOSFET here. I will test the diode. The bridge rectifying diode. This one, we have here short circuit. We have a diode. Two diode have short circuit. This one and this one. I will remove them and do a test again. Before that, I must take a picture or watch the position of those rectifying diode. See, like this one, I enter here. This one at this position, and those are here. So we have here this is are connected together, and those are connected together. So we can see that those are positive, those for the output, those for the negative, and this one and this one, we have the main voltage here. Now I will remove those diodes. I will check the transistor. We have another diode here. We can do a test. This tiny one, it's not shorted. So we will remove those SMD diode. Those are connected between the negative and the positive, so they can give us a chart reading. This one is removed and this one is removed. Here we will put all the damaged part together. Now I will test again. We will test in the main capacitor. We still have a short circuit. This diode is, this one is okay. And this one is okay. We haven't the same reading. So maybe the short is coming from the MOSFET. Now I will remove the MOSFET. I will add some fresh solder. I will use a tiny screwdriver to pull the MOSFET while heating. The first one come off. I will do the same thing with the second one. Second one come off. I will test them for short circuit. This one is for here. They are gone. I will clean the PCB and then test this circuit. If it is still alive, it will give us a signal to the gate of the MOSFET. I removed all the damaged component. This is the input section of the power supply. Here we have 200K resistor. This is the varistor. This is the capacitor, filtering capacitor. This one. This is the resistor, 4.7 ohm, and this one is the common mode rejection filter. And here we can find the bridge rectifier. All those components are burned because they didn't install a fuse. Usually we found a fuse, then we found the varistor. When the varistor explodes, it causes a short circuit, so all the current must flow in this way. And they burn the current, burn the fuse and save the other component here. And in this case, the company didn't install any fuse, not a regular fuse or nor a PCB1. I will now replace the damaged component, and I will see if there is a signal from the circuit. They use this circuit. It's a self-oscillation half bridge driver from International Rectifier. Here we found the two IGBT. They either use IGBT or a MOSFET. In this case, they use IGBT. This one and this one. We have here a half bridge. I will replace the component to get a 600 volt here, or for here a max 600 volt. We must find 320 volt rectified, and I will see here in this pin out here or here. If I found an oscillation, then this IC is good. So I will put a new IGBT or MOSFET, and I will test the power supply. From those PCB, I recovered 4 diodes, rectifying diode, one N4007, and from this faulty PCB, I will recover the filtering capacitor and the varistor. I will desolder the capacitor, it's glued here. We can remove the glue. Now I will remove the capacitor. I will add some fresh solder. I must see the top pins near the bridge rectifier. This one and this one. It's 100 microfarad. I will remove the varistor. This is the varistor. I have here a resistor. It's 6.8 ohm and this one 4.7. So we have the diode and the varistor, the Ford rectifying diode. We have here the resistor, the capacitor. All it's okay. I will put them in the PCB. I will test the oscillating circuit. This is not a varistor, it's inrush current limiter. I tested it with the meter. It has 5 ohm or 6 ohm. I will use those new varistor. They are okay. I soldered all the passive component, the varistor, the resistor, and the 4 rectifying diode and the capacitor. I will plug the power supply and I will see if there is a voltage here in the main rectified capacitor. I will plug the power supply to the socket. I will test if there is a voltage before installing the transistor. Here we have 330 volt. So all the components are okay. Before soldering the transistor, the MOSFET, I will see if there is a switching signal here. We have our switching circuit. We have here 2 output via 100 ohm resistor, the high output and the low output. I will use the scope. Here we can see if there is still voltage here. It's dropping because we have a resistor. Those are for discharging the capacitor, those resistors. I will use this tiny scope. It's not insulated, but I will try to. Here we can put the fix the negative. Here we have the ground, the main ground. I will use a 200k resistor here in the gate, and to see if there are a switching signal. I will power the scope. I will use this tiny this plastic, for example. Here we have the gate of the MOSFET or IGBT, and I will power on the circuit, and I will see if there is a signal. We have a signal here. You can see that we have a switching signal. I will touch the resistor and plug in the power supply. You can see that there is a signal. So I will, for example, adjust the sensitivity to 0.1 volt. I will do the experiment again. I will touch the gate, the resistor to the gate, and I will plug the signal. You can see there is a signal here. Of course, you mustn't touch any metallic part of the scope because it will be energized. I installed the total resistor. Now I will power on the supply and see if it's alive again. I will put the plug. We have a flash here. Oh, now it's okay. We have here the secondary power supply is okay. I put it here a fuse. I will install the fuse here, and I will assemble the motor and see if it's working properly with the motor. Now I will remove the fuse. There isn't a place here for the fuse. I will scratch here. I will remove here the solder mask, and I will put the fuse, so if there is a high voltage spike, the varistor will protect the circuit. It will blow only the fuse. I will put the fuse in series with the input. Now I must cut. Now I must cut here the copper. I will see if there is a sharp screwdriver. I will cut the copper here to insert the fuse. I will power on the. Oh, it's powered. The soldering iron. I will put some solder here. I will cut the leg. I will put some solder here. It's a 3 amp fuse, 3.15 amp fuse. It will be used as a surface mount fuse. Now it's okay. Here the fuse in place. I will now assemble the board and we'll do a test with the motor. I assembled the board inside. Now I will put the power plug. It has the live and the neutral without the ears. Now I will secure it with this plastic. It was used to secure the power plug. This plastic, we must replace the head. Now it's okay. Here we can find the encoder, the rotating disc, and which form the encoder with the optical sensor here. I will plug the motor. It's 24 volt motor. Now I will put the plastic here because we have the shaft here which will be connected to the mechanism. It will be connected to the chain that moves the door. Now I will grab a new remote control. This is the remote control which goes with this opener. I will plug the power. Now I will try to program this new remote to work with this opener. To do this we must press the prog button few seconds until it light up, then we press the button here. Now it's okay. It's programmed. We can hear that the motor works now. Of course it's programmed. We can see here the encoder while it's working. And here we can see the shaft. Now I will assemble the case. This is the case with a toe screw. I will remove the plug. We have here two Phillips screw. Now we can put this cover. So we can do a recap. After replacing all those faulty components, the power supply is repaired. And we installed a fuse. If the fuse was installed, it will save those components. And we will replace only the varistor and the fuse. Usually when the MOSFET is shorted, it takes with him the switching circuit. But in this case, it's not damaged. We have here 100 ohm to the gate, 100 ohm resistor to the gate, and if it was shorted, usually it will be a high current here delivered to the circuit, and it will be burned. Usually, the switching circuit will be gone in this case. But here, it's saved, but it's functioning again. Now we come to the end of this video. Thanks for watching and have a nice time.